The human bone is 4 times stronger than concrete. The strongest and most resilient part of the body is the skeleton. The human skeleton is the internal framework of the body. At birth, the skeleton is composed of around 270 bones. However, it decreases to around 206 bones during adulthood after some bones become fused together. The human feet contains about 25% of all the bones within the body. The strength of human bones is derived from their complex composition. Bones are primarily made up of 2 materials, collagen and hydroxyapatite. Collagen is a protein-based component which provides bones with flexibility and tensile strength, allowing bones to absorb shock and resist fractures under impact. Hydroxyapatite is a mineral form of calcium phosphate, which gives bones their rigidity and compressive strength. The human bone is usually compared to structural materials, such as steel and concrete in terms of strength, due to its powerful mechanical properties, compressive strength, tensile strength, shear strength, and density. The compressive strength of a bone is approximately 170 megapascals, which is comparable to that of concrete. The compressive strength of a standard concrete is approximately 20 to 50 megapascals and up to 130 megapascals for high-performance concretes. This makes bones about 4 times as strong as concrete. Compression occurs when a force pushes directly into a material. The femur, commonly known as the thigh bone, is the strongest and largest bone in the human body. 1 cubic inch of a human bone, especially the femur, can bear a compressive load of about 19,000 pounds. This is approximately the combined weight of 5 standard pickup trucks. When compared ounce for ounce, human bone is stronger than steel. This is why the femur rarely breaks under normal activities, but can fracture in severe accidents. The average length of an adult male femur is 18.9 inches. It can support up to 30 times the average weight of an adult. The skull can withstand a force of up to 6,000 newtons, making it extremely protective. This means bones can withstand a significant amount of weight pressing down on them without breaking. Now, the tensile strength of a bone is approximately 130 megapascals, which allows it to resist pulling forces and stretching. This strength comes largely from the collagen matrix, which enhances bone flexibility and prevents sudden fractures. The shear strength and density of a bone makes it capable of absorbing shocks and distributing forces to minimize the risk of fractures. Bone density typically peaks around age 30, after which it gradually declines. After the age of 30, bone resorption or breakdown begins to slightly outpace bone formation, leading to a gradual decline in bone mass. The rate of loss is usually minimal during this stage, provided an individual maintains a healthy lifestyle. The risk of fractures increases with age due to reduced collagen production and mineral density, leading to conditions such as osteoporosis. 2 primary types of bone tissue contribute to its durability: the compact or cortical bone tissue and the spongy or trabecular bone tissue. The compact or cortical bone tissue is the extra hard outer layer of bones, which is composed of dense osteons. It provides structural integrity and protects against external forces. The spongy or trabecular bone tissue is found inside the bones. This porous structure consists of a network of trabeculae, which efficiently distribute stress and absorb shocks. Bone is a living tissue. It has the ability to heal, regenerate, remodel, and adapt to mechanical stresses. This process is known as the Wolff's Law. It states that bones become stronger in response to increased load and weaker when they are not used. Bone remodeling involves osteoblasts, which are bone-building cells, and osteoclasts, which are bone-resorbing cells. Osteoblasts are cells which create new bone tissue, strengthening areas subjected to higher mechanical loads. Osteoclasts are cells which break down old or damaged bone tissue ensuring that bones remain healthy and free from microfractures. Through this continuous process, bones become stronger when subjected to regular weight-bearing activities, such as walking, running, or lifting weights. When a bone fractures, the body initiates a healing process in which osteoblasts create new bone tissue to bridge the gap, eventually restoring its original strength. Calcium is a vital mineral that accounts for approximately 70% of bone mass. It provides hardness and density, making bones strong enough to support body weight and resist fractures. Osteoporosis is a condition characterized by low bone mass and deterioration of bone tissue, making bones fragile and more prone to fractures. It is mostly common in older people, particularly postmenopausal women.